Okay, guys, so chapter 2. Chapter 2 is polynomials and rational functions. Alright, so the first one says write an equation of a polynomial function in factored form. That it's a cubic and it has the following characteristics. So it gives me 3 roots, which is nice, and then it gives me an initial condition. Okay. Alright, so f of negative 5, f of 1, f of 6, these are all roots. Okay, and another thing that we said, like a synonym for roots, is that they are also your factors. Okay, so if I write each of those as factors, I have x plus 5 times x minus 1 times x minus 6. Okay, now every polynomial has a leading coefficient, right? And right now I don't know what that is, so I'm just going to let that be a. Okay, now this here is your initial condition, which is going to help you figure out that a value. It will help with okay, so I got f of negative 1 equals a times negative 1 plus 5 is 4, negative 1 minus 1 is negative 2, and then negative 1 minus 6 is negative 7 equals negative 3. Okay, so I got negative 8 times negative 7, which is 56. So 56a equals negative 3. So a is negative 3 over 56. Okay, so my final answer now is negative 3 over 56 times x plus 5, x minus 1, x minus 6. All right, so don't forget that you need to figure out your leading coefficient as well. Okay, so 22 says write an equation for the graph below. So this is kind of similar to the last one, except we have to come up with our roots now. Okay, so the first one here at negative 4, I see that it's changing direction once it gets to negative 4. So that tells me it should be x plus 4 squared. Okay, so if it changes direction, it's a multiplicity of 2. The next one, if it just passes through, it's just a single factor. Now the third one here is at x equals 0. Right, now see how it bends through 0. It's changing its concavity at x equals 0. That tells me that it's going to be a multiplicity of 3. So this one is going to be x cubed. Okay, this 2 comma 3, that's going to help me figure out my initial value or my leading coefficient. So I'm not going to use that quite yet, but I'm going to use that in about a minute. And then this one here is x minus 3 to the first, and then this last one here is x minus 5. Okay, so I got a bunch of factors, right? So we're going to say p of x is, again, your leading coefficient, so we're going to just say a. And then you can put them in order. I like to put the root for 0 first. So that's x cubed. And then the rest of them you can write them as they are. So x plus 4 squared, x plus 2, x cubed we already have, x minus 3, x minus 5. Okay. Now it tells me that when I do p of 2, it needs to come out to be 3. All right, so that's going to be useful for me. So I'm going to replace all my x terms now with 2. I'm going to set it equal to 3. So p of 2 would be a times 2 to the third is 8 times 2 plus 4 is 6 times 2 is, or squared is 36. 2 plus 2 is 4. 2 minus 3 is -1. And then 2 minus 5 is -3. And that's equaling to 3. Okay, so that's a lot of numbers. So what I'm going to do is I'm going to use the calculator to figure this out. So I have 8 times 36 times 4 times -1 times -3. And that is 3,456, which I'm sure you guys did in your head. 3,456. A, which is equal to 3. So then A is 3 over 3, 4, 5, 6. Now I'm just trying to see if it simplifies or not. It does, look at that. So A is 1 over 1,152. Okay, so my answer, so P of X is 1 over 1,152 x cubed, x plus 4 squared, x plus 2, x minus 3, x minus 5. Okay, so we'll get back to this. All right, so it says sketch the graph of the following functions. So it looks like I have polynomials and then also rational functions as well. All right, so for the first one, my leading coefficient is negative. And it looks like my degree would be 1, 2, 3, 4, 5, 6. So my degree is even. Okay, so what that tells me is that my graph is going to start down here, and it's going to finish down here as well. All right, so what you guys want to do is just draw your roots out first. So I have one there at -3. I have one there at 1 and 5. Okay, so I'm going to start here. Okay, so as I come up to my first root, I see that my multiplicity there is 3. So I have to kind of like change concavity. All right, they're at -3. You don't want to pass just straight through it. And then when you go to 1, you have to bounce off of 1, like so. And then the last one, you're going to go straight through 5. All right, so that is the graph for f of x there. Okay, so 24, it's not factored for me, but I can do that. So you're just going to do the first two and then the last two. So that's x squared times x minus 6, and then -9 times x minus 6. So that's x squared minus 9 times x minus 6, which is then x plus 3, x minus 3. Okay, so My degree is 3. Leading coefficient is positive. All right, so that tells me I'm going to start down here and finish up there. Okay, so just draw out your axis and your intercepts. Okay, so it looks like my multiplicities for all these are 1, so I'm just going to pass through each of them. All right, so that's your graph for that one. Okay, so 25 and 26 are rational functions, which require a little bit extra work, but not too bad. All right, so for the first part, we got a factor. I'm going to take out a 4. And then take out a 2. So then I'm going to leave with x plus 6. Nope. That's not right. Why am I blanking? Ah. Sorry. And then you got 2, x plus 4, x minus 2. Okay, so what do I need to know? Now I see that I cross out x minus 2. All right, so that's a hole at x equals 2. All right, so if I plug 2 back into what I have left, right, that's going to give me 4 times 5 divided by 2 times 2, 4, 6. That's 6. So I have 20 over 12, which is 5/3. Okay, so at least I know the coordinate for my hole now. I see that I have an x plus 4 factor in the denominator, so that's a vertical asymptote. I see that I have an x plus 3 factor in the numerator, so that's an x-intercept. And then the last part, if you look at the degrees on the top and the bottom, see how they're both 2? So that tells me that whatever my coefficients are of my highest degree terms, that'll tell me where my horizontal asymptote is. So your horizontal asymptote is at y equals 2. So 4 over 2 gives you 2. All right, so let's draw my grid. All right, so draw your asymptotes first. Probably the easiest. So horizontal there at 2. And then vertical asymptote there at 4. The next thing I'm going to do is so I did this, I did that. I'm going to do my x-intercept, which is here. Okay, and then I'm going to do the hole next, which is there at 2 5/3, which is almost y equals 2, so right about there. All right. Now remember, rational functions are typically like opposite areas of each other. So one is going to go here, and then the other one is going to go like that. Now, if you guys didn't know, if you're confused about how to come up with that, what you guys can do would be like a sign chart, which is going to be your vertical asymptotes and your x-intercepts. So I would do like -4, -3, and that's it. So if I plug values into my function, I would get a positive, a negative, and then a positive. Okay? So if you look at how I drew my graph, right, the y values are going to go from being positive, which is up here, and then they're negative, and then once I get to -3, then they're positive again. Okay? So if you have a hard time drawing the graph, always you can do sign charts with your vertical asymptotes and your x-intercepts. Okay, so g of x, I'm going to do the same thing. So I got x minus 3 over x times x plus 3. All right, so nothing cancels, so there's no holes. I have vertical asymptotes at x equals 0 and -3. Horizontal asymptote. Now, if you look at the degree on the top, it's 1, and then on the bottom, it's 2. So if it's bigger on the bottom, it's going to be y equals 0. Okay? And then I have an x-intercept at x equals 3. Okay, that comes from the denominator. And there are no holes in this equation. So do my asymptotes first. So 1 there at 0, 1 there at -3, and then 1 there at y equals 0, and then x-intercept here at +3. Okay, so this one I think I'm going to do a sign chart because I'm not really sure where, because I have 3 areas here. I don't know where each branch should go. So do your asymptotes. So -3, 0, and then your x-intercept, which was 3. Okay, so if I plug in like -4, right, I'm going to get -4 minus -3 is -7 over -4 times -4 plus 3, that's -1. That's 1. All right. So, -7. Yeah, so that's negative. All right. Now, if I plug in something in between -3 and 0, so if I do like -1, -1 minus 3, -4 over. Oops, sorry. This should be negative. All right, so -1. Okay, so All right, so this is positive. Negative over negative. And then if I plug in 1, I'm going to get a negative over a positive, so that's negative. And then if I plug in, say, 4, that's going to give me a positive over a positive, so that's positive. All right. Okay, so it says to the left of negative 3, I need to be negative, which will look like that. All right, use your asymptotes to help you. And then between negative 3 and 0, it's positive, so it's going to come down and then go back up. All right, and then between 0 and 3, it's negative, which will look like that. And then from 3 to infinity, it's going to be positive. All right, so I know I'm crossing my asymptote here, but as long as you kind of stay level, you know, you're allowed to cross an asymptote, or vertical, or horizontal asymptote, but just not a vertical asymptote. So. All right, 27, write the equation for r of x pictured to the right. All right, so this is kind of like working backwards. So, I have an x-intercept at x equals negative 3. I have a hole at x equals 0. 0 and negative 3/2. And then I have, looks like, vertical asymptotes at 1 and negative 2. And then I have a horizontal asymptote at y equals 1. Okay, so, all right, if there's a hole there at x equals 0, right, that tells me that when I write my equation, there should be an x term in the top and the bottom like that, okay? So this part is for the hole. The next part, your x-intercept is there at negative 3, so that's going to go in the top, so x plus 3. And then it looks like you have asymptotes there at 1 and negative 2, so that's going to go on the bottom. So x minus 1, x plus 2. Okay, now it says that there's a horizontal asymptote there at 1. Oh, now I see. I missed the other x-intercept. There we go. That makes sense. We got an x-intercept at x equals negative 1. Okay, so that's going to go on the top as well. That makes more sense. X plus 1. Okay, so we got both those x terms are from the where the hole is, and then these two here are for your vertical asymptotes, and then the top two factors, x plus 3, x minus 1, are for when your x-intercepts. Yeah, so you guys, just, again, if you if you see a hole on the graph, that means that a factor must have been canceled. If you see x-intercepts, those factors go to the top. If you see vertical asymptotes, those factors go to the bottom. Okay, last two for chapter 2. Use synthetic division to find all the roots for the given polynomial. Okay, so I'm starting with an x to the 4th, and it says f of root 5 equals 0. Now, there was a theorem that we did that if you have one radical root, then you also have another one. So the opposite of root 5 would be negative root 5. So f of negative root 5 is also 0. Okay, so right off the bat, I know I have two roots. Now I just need to figure out what the other ones are going to be. So root 5, and then I got 1, negative 7, 5, and 10. Okay, so bring down the 1. So that's root 5. So negative 1 plus root 5. Alright, so then root 5 times negative 1 is negative root 5. And then root 5 times root 5 is 5. So that's negative 2 minus root 5, which is then negative 2 root 5 minus 5, which is then negative 2 root 5, which is then negative 10, which is then 0, which is what I want. So I'm going to move that over here. Move these numbers over a little. Okay. So I'm down 1, and then I'm going to do the other one. So the other one is negative root 5. So you bring down the 1. That's negative root 5, which is then negative 1. Positive root 5, which is then negative 2. And then that's positive 2 root 5, which is then 0, which is good. So now I have x minus root 5, x plus root 5, and then I got x squared minus x minus 2, right? I started with x to the 4th, and I divided by two roots, so what I'm left with is then an x squared. So I got x minus root 5, x plus, and then x minus 2, x plus 1. So my roots are plus or minus root 5, 2, and negative 1. Okay. All right, and then the last one here again gives me a polynomial, and then f of 1 minus root 2 is 0. So then that means f of 1 plus root 2 also should be 0. Okay, so now again I have two factors that I can work with. So 1 minus root 2. You guys might want to spread out when you're doing this one because it's going to be kind of long. Okay. Alright, I'm going to bring down the 1, and then that's 1 minus root 2. So negative 2 plus 1 minus root 2 is negative 1 minus root 2. Okay. So for this, I'm going to have to kind of do it off to the side. I can't really do it in my head. Alright, so that's negative 1 minus root 2 plus root 2, and then plus 2. Okay, so those go away, and then that leaves me with 1, which is then negative 4. And then negative 4 times 1 minus root 2 is negative 4 minus, oops, sorry, plus 4 root 2. which is then 4 plus 4 root 2. All right, so again, I'm going to need to multiply that out because I don't know what it is in my head. So 4 plus 4 root 2 minus 4 root 2. 8. All right, so that's going to give me negative 4, which is 0. Okay. All right, so I'm going to minimize this. Okay, so I already did the one factor. Now I know I can use the other factor. So 1 plus root 2. Okay, so bring down the 1. That's 1 plus root 2. So the 1s will cancel, the root 2s will cancel, so that's 0, 0, negative 4, negative 4, minus 4 root 2, which is also 0. Okay, so I have x minus 1 minus root 2, x minus 1 plus root 2, and then x squared minus 4. So I factor that. So that gives me 1 plus or minus root 2, and then plus or minus 2. Alright guys, so that's chapter 2. Again, if you have any questions, please let me know.